Hello, everyone. This video is just to clear up any confusion you guys have on factorials. We're going to be using factorials from here on out, starting in section 11.6 and for the rest of the semester, really. So just want to make sure everybody's on the same page. So remember that n factorial, which is how we say this n exclamation point. Okay. So n factorial, what is that? That is equal to n times n minus 1 times n minus 2, and so on, all the way down to times 3 times 2 times 1. Okay. And that's kind of working on the assumption that n's bigger than 3. Okay. Basically, what n factorial is, we're just multiplying all the way down to 1. Okay. So for example, 4 factorial, that would be 4 times 3 times 2 times 1. Okay, and if we multiply all that out, we get, what, 24. 2 factorial. Okay, well, that would just be 2 times 1, which is 2. Okay. 5 factorial. 5 times 4 times 3 times 2 times 1. Let's go to 120. This factorial is only defined for integers, okay? So we only want to be working with nice whole numbers greater than 0. Factorial, there's something called the gamma function, which kind of extends the idea of factorial to like real numbers, but we're not going to mess with that at all. So when you see factorials, just, it's all about integers. Note that 0 factorial, you might think it's 0, but it's actually 1, okay? And that doesn't really seem to make sense with what I've set up here, right? Like how do we do 0 factorial and end up with 1? So this is not by the formula, it's, we would just say it's by convention, okay? So when we see 0 factorial, we just say, okay, that's equal to 1. Okay, why is that? This is not necessary for you guys, but if you wanna know, I'll tell you. Excuse me, my screen's all over the place. So factorial, where did factorial come from? The factorial came around when people were like looking at a group of n objects. So let's say we have n objects, and we want to figure out like how many permutations of n objects are there. Okay, what is a permutation? You can think of a permutation as just like if we have n objects, we're going to line them up, okay? And how many different ways to line them up are there? So let's say I have like the letters A, B, C, and D. Okay, how many different orderings of these letters are there? Like I could do A, B, C, and D. Okay, I could do A, B, D, and C. I could do A, C, B, D, A, C, D, B, and so on, right? So how many different orders are there? And that's just the A's, right? And then I could, maybe start with B. I could do BA, CD, and BA, DC, da, 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 da. So how many different like ways to order those 4 letters are there? Okay. So that's where factorial came in, and that's what factorial is. If you have n objects, okay, there are n factorial permutations, or if you want to think about it this way, there's n factorial number of ways to order them. Okay. All right, so how does that relate to the 0 thing? Well, if I have 0 objects, how many ways to order 0 objects are there? Well, there's just one way, right? That's why we say 0 factorial is equal to 1. Okay. If I had 3 objects, well, there's 3 times 2 times 1 ways to order them, right? So if I had like A, B, and C, how many ways to order these letters are there? There's 6, right? There's A, B, and C. There's A, C, B. There's B, A, C, B, C, A, C, A, B, and C, B, A. Okay, so 6 ways. 1, 2, 3, 4, 5, 6. And that matches up with our idea. Okay, 3 objects, 3 factorial ways to line them up. Okay. So that's kind of where factorial comes from. This idea of ordering stuff is not really necessary for you guys. I would know this if you just want to memorize that. That's fine. Okay, what we're going to have to do is we're going to have to do a lot of work with factorials, and in particular simplifying factorials. Usually when we're simplifying these factorials, we're simplifying fractions of factorials. So let's look at several examples and see how we simplify these. Okay. So let's say I have n factorial over n plus 1 factorial. What does that simplify to? Okay. Just if you're ever in doubt, just take it to the definition. What is n factorial? That's n times n minus 1 times n minus 2, and so on, all the way down to 1. Okay. And then what's n plus 1 factorial? It's the same thing. It just goes a step further, right? So notice that like I got an n on the bottom and on the top. N minus 1 on the bottom, n minus 1 on top. Boom, boom. So all these terms cancel. The only thing that's left over is this n plus 1. So this simplifies as 1 over n plus 1. And now I don't have any factorials or anything. It's just n plus 1. Okay. You could also think of it as this. Okay. If you want, so this is kind of how I usually think of it. You could also, there's, it's the same thing, but maybe a little neater. You have n factorial over n plus 1 factorial. Well, how could we write n plus 1 factorial? N plus 1 factorial is the same thing as n plus 1 times n factorial, right? And now I see the n factorials cancel, and I'm left with 1 over n plus 1. Okay. So if you're comfortable with that, you could do it that way as well. Let's see another example. How about 2n factorial over 2 times n plus 1 factorial? Something to be careful with about factorials is where the factorial is in relation to like parentheses. Okay, so I have parentheses factorial. What I'm taking the factorial of is the 2n, right? So that numerator would be 2n times 2n minus 1, dot, 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 all the way down to 1. What's going on with the denominator? I have 2 times n plus 1, then I'm factorial. Okay, so let's see, what would the first term in the denominator be? It'd be like 2n plus 2, right? And then I'd subtract, the next step would be subtract 1. I got 2n plus 1, and then 2n, all the way down to 1. Okay, so what's getting canceled? This is canceling with this, and so on. Okay, and what am I left with? I'm left with 1 over 2n plus 2 times 2n plus 1. So that's my simplification there. So that's something to keep an eye on, the parentheses in your factorial. And then n factorial, this is just kind of, we're adding something to the factorial in the parentheses. So how will we simplify this? Well, I got n times n minus 1 on the numerator. And then what's in the denominator? N plus 7 times n plus 6. And then I work my way down to n minus 1, and that, things are canceling now. Okay. So this n cancels with that n, and so on. And what would I be left with? I'd be left with a lot. But it would stop there, right? That's all I have. So it doesn't go all the way down to 1. It just goes to n plus 1. Okay. So hopefully this gives you some insight on how to work with factorials. As I said, we're going to be working with them from now on. So bone up on these, very important.